All right, folks, thank you all for being here. Right about noon, so we're going to go ahead and get started with my quick introductions, and then we'll transition into today's actual presentation. But thank you for being here for our Passive House Lunch and Learn. Today, we have a special session on wood fiber insulation. We have Scott Johnson on the screen here. You may be able to see he's with Timber HP, business development manager with them, and he will be leading today's presentation. But first, I want to take a couple moments to thank Mass Save for helping to put on this event and many others that they've been sponsoring here for the last 4 years or so, and expanding to cover all electric homes programs as well. I'm sure all of you have heard about the Mass Save programming so far at PH Mass. We've been partnering with them to put on events like this Lunch and Learn and many other things which you can find recordings of in our video library. But thank you to the sponsors. The all-electric home incentive might be the new one that some of you haven't heard of. This just came out beginning of last year, and this sort of aligns with the updated stretch codes here in the state a little bit, but it's based on those on first score performance rather than passive house. So it's for single family all the way up to 4-unit buildings. Some pretty good incentives if you're making efforts to become all electric, and you can see in the chart what type of all electric or electrification readiness things they require for those projects. But very good incentives here, and it's great to see them incentivizing the 1 to 4-unit buildings. Of course, for the last 4 years or so, they've had these passive house incentives going for 5 units or larger buildings. Over 10,000 units of multifamily housing are now enrolled in this program, and incredibly successful. So it's really great to see that. But if you're unaware, here they are. And like always, I encourage projects to, at the very least, take advantage of the feasibility study incentives to explore the idea of passive house, get your feet wet with it, and see if it works for your project. And even if it doesn't, you still get that feasibility study covered. So thank you to Mass Save. We won't take any questions on these incentives right now, but I will say that Mass Save is also incentivizing professional certification. So if you want to become a certified builder, certified consultant, and so forth, you can get half of the registration costs reimbursed through Mass Save. So look at them, look at our website, phmass.org, for info on there. I'm going to go ahead and stop my screen here. So Scott, you can get yours going. But welcome to today's session. So like I mentioned, this is on wood fiber insulation. This is a product that some of you may know. It's been available from some European countries here for a few years, and some folks have been using it here. We've seen presentations at other events on it due to the fact that it's very low carbon. But I'm not going to talk too much about that. I'm going to let Scott take all that. But one of the reasons we set this up today is there's a new company here, Timber HP, located up in Maine, which is going to be producing this type of material, this wood fiber insulation here right in New England, making it hopefully a lot easier for all of us to access. So I'll let Scott go through the presentation today, talk about what the material is, what's available, give a little background on wood fiber overall and sort of how it's made. For questions, feel free to use the chat room. Definitely ask whatever you're interested in. We might take some questions during the presentation, but most of them we'll get to at the end of today's presentation. But as they come up, as you want to discuss things, definitely just use the chat room to type things in there. So Scott, take it away.
Thank you, Aaron. And thanks everybody for making some time today to visit with us. I'm hoping that you're able to see the lead slide, which is Timber HP by GoLab. As Aaron said, my name is Scott Johnson. I'm the business development manager for Timber HP. My background is I've been in the building materials industry pretty much my entire professional career, working with the likes of Andersen Corporation, Andersen Windows and Doors throughout the Northeast, as well as Huber Engineered Woods. So have worked a lot, not only in the field, but also with developers and architects. And so chances are maybe a few of you I've run into over the years, primarily all throughout New England. So that said, what we want to do is give you a little bit overview of wood fiber insulation. I think many of you have been following it for some time, and I'm just going to let my computer catch up with me here. There we go. So many of you have been following the European story in the journals, or perhaps some of you have actually worked on some projects where you've actually imported it into the United States. We'll touch a little bit on that because some of you, perhaps this is fairly new, but as a new company starting out in the building materials industry, particularly here in New England, you know, it's depending upon who your customer is, there's a lot of intrepidation, right? If it's a new widget, if you will, a lot of folks like to use what they're accustomed to. So when you start to get into a new segmentation and it's a new product. A lot of folks are very skeptical. So as we bring this market into the United States and we actually start producing it up at our Madison mill, we like to lead with, what is wood fiber all about? What is it? We lead with Timber HP. That is our go-to market name, and timber obviously means wood. The HP really stands for high performance, healthy planet, and healthy people. We like to get into conversations, particularly with the builders and the installers, in the sense that, look, this is indeed a high performance product. Not only does it help with the longevity of the enclosure, but the materials that you're physically installing into the building are very durable. So we like to get them to be very comfortable. We also like to really clearly articulate where this product fits. And this product fits above foundation grade. So if you're thinking about a wood frame building, be it light commercial, 4 stories or less, or certainly residential, great fit for that, both for new construction, remodeling, additions, and a tremendous amount of opportunity as well for weatherization programs too. So then we roll into the discussion on healthy planet. We'll get into some more details as we get into the presentation. And what's very unique and different, this is an extremely interesting category, the insulation category. And with the exception of perhaps cellulose, most of the materials that are used have a very high embodied carbon. And, for obvious reasons, they're trying to provide a great product for thermal and for sound and for durability. And there's a lot of great attributes that come with those products that are currently available today. But unfortunately, there is indeed a high embodied carbon piece. So when you look at wood fiber, it's pretty unique and different within this segmentation. We're actually using fall down material from production of milled lumber or interior trim. We can also use treetops and branches. So we can really use quite a bit of the excess material that's not wanted for upstream production, and we can integrate that into a wood fiber solution. And we're also using non-toxic chemicals, which we'll get into in great detail. And then we also talk about the healthy people, because not only is it the occupants that you see on this screen right here that will obviously be immersed in the use in terms of open wall assembly, open flow assembly. There's no toxic. That's a wonderful thing for those occupants. But the individuals installing this, if you think about it, whether it's X, Y, or Z, you pick the material. Most of the materials that are going in for insulation, for thermal and or for sound, for those installers, it's not the most enjoyable installation. Many of them have to suit up to be able to make sure that it does not provide any harm to them. So we've had a lot of great feedback. I was just recently over in Millbury at the Massachusetts Union Trade Center for training, and it was fun to work with the students when they were picking up our samples. They actually could pick it up without any gloves. They liked working with it, cutting it, and it was a different experience for them. But the 40,000 foot overview as it relates to wood fiber, it's truly a new product here in the United States, being made in the United States now. Up until this point in time, it has been used in the United States, but mostly as a boutique product that's had to been imported and comes with an extremely high price tag. So what we're trying to do is bring this into the market where it's affordable for everybody. Mid-tier, residential, multifamily, affordable multifamily, etc. And what this brings into this segmentation is a product that in essence is carbon storing. So we can take some of that waste stream, and we'll show you more detail on how the product's produced in a little bit. But we can sequester that carbon, that wood fiber, into a viable commercialized material that can be used for insulation as well as for sound abatement. And you can see on the right where the product fits. It certainly can be used in an attic application. It could be used as a timber board on the roof to the exterior. Certainly it can be used in the cavity bays, both for the roof as well as the wall. Think of blown-in insulation, if you will. There's also a batt insulation, as well as then the exterior continuous insulation. All of them are made from wood. 90 to 95% of the products are all made with wood. We introduced the high performance discussion because now what we're trying to do, of course, we're trying to address code and minimize thermal loss and make sure that we're not having too much to contend with operational carbon, both for heating and cooling. And what's interesting here is we're allowing a flow-through assembly to dry out in both directions, hence the high performance. We're managing air movement, moisture, and conductivity, very vapor open material. The material in and of itself, we can recycle the material. It certainly could be used and repurposed as well. And the materials that we use as binding agents are non-toxic, and we'll get into details. We always get the questions as it relates to wood fiber about fire, bugs, and water, and we'll address that in great detail. But obviously, to come to the United States and sell it into the market, you have to go through code verification, and we will do that. And we'll show you the various makeups of each particular product to help give you a better understanding of how that works. The fun part of it is that for many of you, you've heard about Go Lab or perhaps Timber HP more recently, because that is our go-to market. And you've heard about it for a number of years. Well, I'm happy to report that last month we were able to finally flip the switch on our first product line, and we're starting to produce what we call Timber Fill, which is an alternative to the cellulose manufacturers, in essence, recycled newsprint. And that is up now in the code verification standpoint. We're about 3 weeks away from having this viable as a commercial product, good to go. And the good news there as well for us and for you too is that we're using the same channel. So for those of you that are familiar with cellulose product, use it perhaps in some of your design, or if you own your own installation company or sub out, they'll be able to procure this through their traditional cellulose distributors. We just absolutely wanted to make it simple for people to plug and play. And my guess is 80% of the folks that are procuring current cellulose will find that those folks will have access to the Timber HP product. That really makes it affordable as well. The Timber Bat, we're going to start to play in the manufacturing facility with this particular product in July and August. So we'll be bringing up that equipment and dialing in our quality assurances. And as soon as we get it to the point that we're comfortable with it, again, we'll push that out to third parties to get tested for code viability. And we're looking to have that possibly late August, but early September for that particular product to be ready. And then the timber board, that would be the continuous insulation. We're looking to produce this late third quarter into the fourth quarter, and hoping to get all of our various commercial documentation ready for late December, if not early July. And both the timber bat and the timber board will be going to market through traditional lumberyards. We will not be in the big boxes. We really want to focus on the independent retailers. They have the ability to store it. They have the ability to procure it locally through Cameron Ashley, our distributor, as well as LBM Advantage. Those two names may not mean anything to you, but it really is something I reiterate in these conversations, because it allows these retailers to have a readily supply of this material. Again, we're not importing it, making it here in the United States. And the only way to make it economically feasible and competitive is to have it readily available. And that way, as you're speccing a project or you want to use wood fiber, whomever is procuring that material has the ability to go out and competitively price out this material as they would with any other type of building material that you're using. So by the end of the year, we'll be good to go, and the sources will be ready. I did also want to take a point to make sure that for those that are not familiar with wood fiber, to just give you a bit of an overview, the market for wood fiber has really been 20 to 25 years viable over in Europe. And these names that you see on the screen have been imported into the United States, mostly Steico and Gutex. Those are the premier products that have been being brought in. 475 out of Brooklyn, of course, they've been bringing in some of these materials over the years. Their market is only 30% wood construction. And even though that's a small percentage, ours is 70 here in the United States for built-in construction per annum. There's still 15 manufacturing facilities over there, with 5 more under construction. Steico is a $500 million company traded on the Frankfurt Exchange. Point to this is the fact that this is a viable market over in Europe. We're a little late to the game here in the United States, but now we're bringing it in here to the United States to manufacture it so that we can drive down these costs, and I'll talk a little bit more about it. But again, for those of you that are new, and if you can't hear the audio behind it, that's okay. I wanted to show a little bit of a video so that you can get a good feel of how they're using it in Europe today. and take a look and see what's unique and different in terms of the installers. And it's always nice. The first slide will show you the Alps in the background. So it's an interesting video, and for those of you that have never worked with the wood fiber, I hope that video did a nice job of showing you really how straightforward it is to install it. And I know that if you're a builder or a subcontractor and you're on the call, you know, anytime you're using something for the first time, there's a lot of intrepidation. Rest assured, on our video, or excuse me, on our website and such, we'll have all kinds of best installed practices for you, not only for the architectural details, but also for the field folks that install it as well. I don't know if we said it at the beginning, but there will be some resources that I'll pass along to Aaron to push out to you. And one of them will be this video that we will not show during this call. It's about a 5-minute video. It's a fantastic video that will give you oversight into the origin story of GoLab, aka what we go to market with now, Timber HP. And it's a really fascinating story, primarily discussed by Josh and Matthew, the two fellas here that you can see on your slide. These are the two co-founders, and they discuss, you know, why has this material not been in the United States, and you know, what is the reason that Europe is so far ahead of us. I will leave a lot of that for your imagination, and then you'll be able to see it on your own when you get a chance to click to the link. But really, out of frustration, you know, Matthew Elmalia has owned his own firm up in Belfast, Maine, as a passive architect for years, and he's been working on operational carbon, driving down carbon consumption for cooling and heating. And he met through mutual friends, Josh Henry, who's an academic, a professor at the time up at the University of Maine, and prior to that at Maine Maritime, and studied at Cornell University, PhD in chemistry. They both live in Belfast, and Matthew brought Josh over to one of his homes, and Matthew was very excited about the low carbon consumption, and Josh, not being from the industry, looked at it and said, well, all you did is put a trash bag over that building. How can that be good? And then thus began an amazing relationship, and I'll let the video speak for itself. They do a fabulous job. But really, they did try to get the folks from Europe to come over to the United States. They were, in essence, being ambassadors for the state of Maine, for the forestry industry, trying to get Europe to come over here, one of those firms that you saw in the video. But with no luck, the two of them, they've got Moxie, being from Maine, and they went out and actually formed the business that you see here today, that we're really excited about being able to flip the switch on manufacturing. That plant that you see in the forefront to the left, that is the mill up in Madison. And that is a paper mill that was defunct in 2016. I don't have to tell you on the presentation here, but the phone, the digital media, if you will, has destroyed the paper market. There's very little paper being produced in the United States. This particular mill was making the high glossy inserts from the New York Times. That mill, again, was defunct in 2016 with 150 people losing their jobs. That equipment was put in a container, several containers, and shipped over into Asia. And with an infusion of cash, which we'll talk about in a minute, this plant was purchased by Josh and by Matthew and repurposed engineered by I'm going to say Steico, but it's incorrect. I don't know why I'm drawing a blank on it. I've said it 100 times, but the engineers out of Boston has redesigned it. And Chimbro, which was the original manufacturer of this facility in 1984, 1986 timeframe, came back and repurposed this mill for us. Stantec is the engineer. Sorry, I hit a little bit of a mind bend there for a moment. But in order to be able to bring that facility to bear and produce product, you actually need some funding. So if you can imagine, you're an architect and you're a chemist, and you're going out and saying, hey, you know what? I need upwards of $130 million to make wood fiber. That's an interesting proposition. And to go and ask for capital from independent investors and or banks such as Citigroup, that's a head scratcher. But lightning struck in a bottle in a wonderful way, as it has in many instances with this company. Tony Grassi, who's the board president, had worked on Wall Street for years, and he's very philanthropic and has done a lot of work with non-for-profits. And he met both Matthew and Josh, and they formed a fabulous relationship. And they were able to take their idea, their concept to make wood fiber here in the United States and put forth a sustainable financing documentation that I'll forward to you, and you'll get that from Aaron. And really what it was allowing them to do was to procure an $85 million green bond from Citigroup and get that approved. And they did that in December of 2021 to finally give them that chutzpah that was necessary to raise another additional $65 million from some private pension funds and a couple companies up in Maine. If you've come up to this part of the Northeast, you probably are familiar. We have investors from Hancock Lumber, Ware Butler, Viking Lumber, SW Collins, and then Robbins Millwork. So we've been able to procure that money to be able to buy the equipment from Germany, which was then imported into Belfast, Maine, and is now in place at our facility in Madison, Maine. And that financing has allowed us to get this mill up and running. And you can see from these various bullet points here, we obviously check the box as it relates to the contribution for sustainability. And we do so in a really positive way, particularly here in this insulation category, which desperately needs it. So this rendering that you see, if you were to drive up to Madison, Maine today, you'd actually see this fully fitted now. This is 100% done. We're receiving raw material, and we're starting to, as I mentioned earlier, we're starting to produce that fill. Couple of other things I mentioned, lightning in the bottle. Here, what's wonderful is the fact that we were able to grab some local folks that had worked at that mill with some incredible intellect. They know the operation of that mill. Thankfully, Marty was able to get in before the recycled material. They were coming in for the paper mill equipment, but the scrappers were coming in and gutting out everything. And Marty was able to save the fire suppression and the electrical systems, so that helped to reduce any new costs to put in place new equipment, because Marty and Rick and Joe and Steve were able to repurpose all of that so that we could save that expense, which, as you can imagine, for an upstart, anything you can save of that kind of capital to put out for some of that new equipment is just a blessing. So we've got, a lot of folks that are now coming back to that mill. We're about 85 folks strong. We'll have about 120 up and running when it's done. So that's the background story. And really, this is the essence of what wood fiber is. And I think the simplicity of it is just so wonderful. And I think it'll make more sense as to why wood fiber is a viable option to what we've been using in the right application. Just as a reminder, we're talking about above the foundation grade, anywhere where you typically do a enclosure that's a wood enclosure, that would be type 3, type 4, type 5 is really where you would find that wood fiber is appropriate, both for thermal as well as for sound abatement too. But obviously the folks that are milling up a tree, you're going to maximize that as best as they can, right on down to the bark that's going to be used for bark mulch. They're going to grab as much dimensional lumber out of that or interior trim as they can, but nonetheless, they're still going to have waste. And that's what the paper mills were picking up. And there's only about 2 left. So there's a lot of that material that no longer could be sold to the paper mills. And what they would do in the interim, and some still do, is they're burning it off as biomass. Now, the only downside to that is there's some carbon release to do that, but at least they are getting some electricity from that. But now with our facility back up and running, we're able to pick up and repurpose that wood fill. And what we're going to do is, instead of make paper, we're going to finely ground that material into that third photo from the left over. You can see that finely ground material. That's really what we're looking for. We only use about half of what the paper folks would use because, of course, they're trying to flatten it out. We're purposely trying to grind that material, but allow for air to get in there to provide the insulation purposes. So once we grind that material, you can see a little bit of a dropper in that photo there. We're going to put some additives into that, depending on what we're making, and we'll get into details in a minute. And we're going to then push it off into 3 different production lines for the fill, for the bat, and then for the continuous insulation. But here again, just to pick up, we're able to help the forestry industry by coming in and being a viable manufacturer of wood fiber insulation. So we're bringing in a new manufacturing base to help offset some of the loss of the paper mills. And that's a great thing. And, we are, again, the first US-based, first North American facility here in Madison, Maine, to produce wood fiber. And for all the different things that we invested in this, it's wonderful to help with the forestry story. It's fabulous to bring back the people back into that mill. And what it also finally allows us to do is bring this wood fiber insulation into the United States at an affordable price. And when we're up and running, we should have 130 folks back in that mill and about 120 million in annual sales. When you look at the entire United States, this is really the fun part of it, particularly if some of you on this call do work throughout the US. I mean, we're in Madison, Maine, 400 to 500 miles is the sweet spot, if you will. Beyond that, we're really not having a good story on the transportation cost at that point. But when you look at the United States, Maine, of course, is a fabulous state, lots of forestry. But look across the United States, there's a lot of other prime locations in the United States where there is some fantastic forestry as well as production, be it plywood mills, dimensional lumber, OSB mills, and there's a lot of them throughout the United States. So the fun part of it is our vision, and we're going to be starting pretty quickly here next year. We are going to announce our second plant, which would be in Oregon, and we'll be right out by Weyerhaeuser in Boise, being able to take their fall down material and put that into the wood fiber production out in Oregon. And then we do have longer term vision where we would like to, as you can see the logos sprinkled throughout the United States, where we'd be able to put up other facilities to be able to be more local and reduce that distribution piece. In the interim, what's fabulous is the fact that we are partnered with Cameron Ashley. Again, a name that may not mean anything to you on the call, but the purpose of me bringing it up is that they have warehouses throughout the United States. That allows us to push our product, particularly in the New England as well as in the Mid-Atlantic area. That allows us to push those products out into warehouses so that as projects are designed and people are wanting to procure that material, it's there locally for them at an affordable price. So that's an important piece for us to have in play, which we do. So from a price perspective, gone are the days where you have to go back if you had been wanting to use wood fiber and say, hey, I'd really like to use this imported material from Europe, but it's 20% more. Now you can go back to your owner of the building, be it residential or commercial, and say, hey, I have an alternative and it won't break the bank. If you look at the timber fill, we're right on par with cellulose. And being that we're here in Maine, you might find that we're going to be a little bit less in some instances. They're having a devil of a time trying to find the newsprint, and they're having some really difficult times with the consistency of that material. So their prices have gone up. As it relates to that exterior continuous insulation, the timber board, as we call it, we're going to be in parity price-wise to foam. So if you've been using foam and want to look towards an alternative, again, we'll be right on par pricing, and we'll actually be less than the mineral wool material itself. So there'd be a deduction if you have been using the mineral wool. We'll have an alternative for you there for those applications. Fiberglass still gets us. I mean, fiberglass has been manufactured since the 30s. They've got that down pretty efficient, and they can roll it up into compressed sleeping bags and put a lot of it on a truck. Ours is very dense, so fiberglass will still get us on the price point. But if you've been using a mineral wool, you will again find for our bat, be it for thermal or be it for sound, will be a price reduction for you there as well. So I'll pause, Aaron, and see if there's anything that has come up that we might want to address now.
So we don't actually have any questions so far, but a reminder to folks, please use the chat room to ask questions. We can get to some during the presentation and the rest we'll address at the end. It's going really great so far. Keep going.
Thanks, Aaron. Thanks, everybody. So here's the nitty gritty as it relates to those three specific products that we discussed. And the first one is timber fill. And as the applications here on the screen says, dense pack cavity insulation and stud walls between rafters and joists, and obviously up in the attic. I just want to reiterate the fact that fabulous for new construction, but this is a wonderful product for those of you that are doing some abatement where you're looking for ways to help on weatherization programs. Very competitive, easily sourced through those distributors that we mentioned, and an extremely easy one-for-one swap. 1 minute they could be throwing in a cellulose bag, the next minute they could be throwing in a timber fill bag. It would be the same equipment. They might need to vary the speed on their machine, but not much. It's an extremely simple plug and play drop in compared to the cellulose. We are using on all three products, we're using softwood, and there's a reason for it. What helps us with the softwoods is that the fiber is longer. And in these particular applications, when you're blowing it up into the attic space, that allows that material to not settle as much and allows more air into that space. If you think of a hardwood, that would be a heavier fiber and that would settle a little bit more, packing it down. The other benefit is it's less expensive than a hardwood residual, and it's also less of an abuse on our knives too. So that's why we use the softwoods for all of our products. In this particular timber fill, the only additive that we're using here is a liquid borate. And that's a mined material. It's a non-toxic material. That's helping us with the fire, particularly. That's allowing us to get to an ASTM E84 flame spread A. The insects don't like to eat it. And then if you did have a failure in that roof or in that wall cavity, and if the material ever did get wet, because we're saturating that with liquid as opposed to dusting it on, it won't shed off the material and it'll do what it's designed to do, and that's going to mitigate mold. So it would not allow the mold to grow. And then the other nice piece of it is there's no off-gassing. There's some chemicals that have been used in the cellulose market and they have a pungent smell. We're paying a little bit higher for that borate for a reason, for all those fire bugs and waters, but it also does not off-gas with a smell if it was to get wet. 3.8 per inch, very competitive with the cellulose. We're actually 3.8 and they're on average about 3.7 per inch. So it does a nice job there. And again, in the blown-in insulation for demising walls, for example, that can be used for sound abatement as well too. The bat, as I said, it's denser. It's a really wonderful product to work with, very easy to work with. Don't need to wear gloves. You literally brush it off your clothes, easy to work with. Here again, thermal, but also can be used for acoustics. And again, the softwood material, we're using that liquid borate acid. We are introducing a PMI. It's a polymer. It's polyester, if you will. We've looked at soy-based material, but the actual fossil fuel to create that soy base is higher than utilizing the PMI binder as it is. Rest assured, Josh will continue to look for other adhesives to use, but that really gives us that form that you see in that finished good. And it's about 5% by weight in that material. So 90 to 95% is purely really the wood material itself. So this particular product has the borate as well as the PMI. Again, both are non-toxic. These bats can be used in traditional wood frame construction, but can also be used in steel. And we say that because we do see a wonderful opportunity to get into some light commercial, non-combustible applications. And oftentimes, as you all know on the phone, sometimes people will go with steel in lieu of wood, depending upon what these materials are doing in the markets. And that's fantastic so that we can provide, these bats into either wood or steel framing, 16 and 24 inch on center. And then you can see the nominal dimensions really supporting either 2x4 all the way to 2x8 or your steel framing. Here we're at an R4 per inch. And the reason for it is that there's more air that we're able to provide into this space. It's able to bump up that performance. And again, the sound testing on this is fantastic. We're getting some very comparable, if not greater sound density for abatement with this material versus some of the common mineral wools that are available for you today. And then we like to burn things. Now this video is really for those of you that are not familiar with borate. It's an amazing material and it's really staving off that combustion. We put a blowtorch. If that was just sawdust, that piece would have already been consumed by fire. But the flame spread is being minimized, and that's what's helping us get to that ASTM E84 flame spread A. And once that comes off that product, you'll notice that it'll extinguish itself. So it's an extremely phenomenal product for us to use into that product, and that's why we use it. And then the last product that we have is the timber board. Obviously, continuous insulation is, for the last 5 to 10 years, has been very popular. Of course, code now is pushing a more robust exterior R value. And I'm happy to report that we'll have 1 inch all the way up to 9.25. Think of your friends up in Burlington, Vermont. They would like that. Maybe down here in Massachusetts, not so much. You wouldn't need to get to that thickness. But the material in itself now has changed up. Of course, we're using that wood fiber. We're still using that soft fiber that we mentioned. But now we're outside the building, so we're going to change it up a little bit in terms of the additive content. We're using an MDI resin. And for those of you that use OSB plywood, they use an awful lot of that. Think of it, Vantech, very robust product. And then their zip system, they use MDI resin. We're going to use trace amounts of that, not nearly the amount that they need, because we're really just making a thermal insulation product. This is not for shear. This does not have holding power. This is an overlay onto that exterior, as you can see on the left. So whatever your traditional design element is for your shear and for your bulk water and for your air, you would pretty much use that same thought process that you've used. And instead of overlaying the mineral wools or the foam or an R sheeting, for example, you would be overlaying the thermal board from Timber HP. So if you're used to the mineral wool, our product would detail out very similar to that with a rain screen. We'll have a lot of direction, not only for the architectural details, but also for the installers. A lot of direction will be put forth on our websites to help people understand how to flash appropriately and mechanically fasten for windows and such. Here we're getting, depending upon your thickness on the board, and we publish it for each product, you're going to have 3.4 to 3.70 in R value performance. We purposely gave up a little bit of that R value, and the reason for it, you can look at your camera. I have a sample here in my hands. If you're used to using mineral wool, it's a little spongy, and we put that MDI resin in it to get that PMI, that the pounds per square inch, forgive me, up a little bit more robust. So as they're mechanically fastening this to the sheathing and then they're ratcheting down, torquing down on their screw, they're not going to find it. They're going to find more resistance to the torquing, where it would take that wood rain screen and torque it in too tight, because if the installer's not being mindful of what they're doing and they're putting in inconsistent depths on that rain screen, it's going to telegraph into your exterior cladding. So we purposely went a little bit more robust to make it easier for that installer and to kind of negate, if you will, that concern about telegraphing whatever that exterior cladding that you're going to be using. In addition to that MDI resin, we're using paraffin. And both of these materials, as we steam and then dry, and then we start to slice and dice and cut that material up into finer wood fiber, we're blowing that material. And at that point, we're going to be blowing in the MDI and the paraffin into the product. So it's completely saturating that wood fiber. So once that board is completed, all of us are very familiar with the job site. So we're producing products that are performing well, but we're also thinking about that installer. So if somebody chunked out a piece of this wood fiber, because that chemical is monolithic through that material, if you chunked out a piece of this and exposed it, you still have that MDI and you still have that paraffin, so that you can have that water flowing off of that material. We do have a 6-month exposure on the wall and 3-month exposure on the roof applications. And once the cladding is on, obviously at some point, something will breach, especially now lately, we're growing a lot of mushrooms out there with this particular weather, right? And we've had a lot of horizontal rain coming at us. So we know that over the life of that building, some of that water is going to bleed in through the assembly and hit our product. That's perfectly fine. If you're building a wood enclosure system and following the American Panel Association, et cetera, for bringing a 1/2 inch off the CMU and following all your best practices, our material can get wet and hold up and it will be fine. We have a 40 to 70 perm. So if you have some of that driving rain or a cladding failure, as long as our material can dry out, it's quite robust and will hold up quite well. This slide is going to show you the water draining off that paraffin. And then to the left, what it's going to show you is that durability piece. This is up at Mount Desert Island. It's the College of Atlantic, this job. Very traditional Northeast construction. You can see the zip system there, that red sheathing. And then in lieu of mineral wool, they're simply using the wood fiber application. And you can see our wonderful OSHA certified stairs. That's really not good to see, but what we like about it is the fact that it shows the durability of the material. It shows you that it's sitting on some sand on the job site that's actually wet, and people have been walking in and out of those on top of that continuous insulation, which is wood fiber, during a good stretch of that production of that job, and that material is still holding up very well. We're going to be obviously wanting to make sure that we're providing you with all the information related to code, wherever that may be that you're building in, or designing in the United States. So all of our products will be, in fact, right now, today, if you wanted to jump out onto ARCAT or jump out onto our website, you'll be able to see our specifications. And so for all of these products, even though they're not all ready from a commercial standpoint right now, we know you might be working with projects in the 3rd and 4th quarter or into next year. Our specifications there for you to be actually able to put this into your projects. In addition to making sure we hit and exceed what you need to verify for code, we do want to make sure everybody's aware of the fact that because the material is so vapor open, is you can leverage what it is that you're wanting to use for that shear strength and for your bulk water and your air management. But if you've been using foam or an R sheathing polyiso, what we're trying to do is get rid of this detail here. In those instances, you're working with the modeling from code to make sure that the dew point during that January, February time point does not occur. It might occur in an anomaly over a couple of days, but you certainly don't want that happening for 2 to 3 months, because you potentially could rot out the back of that plywood or that OSB. So what's interesting here with the wood fiber is that we're able to then now look at that entire wood assembly and actually have a vapor open assembly. No changes in your detailing other than the fact that you might be using wood fiber as opposed to something you've been using in the past. You're going to be using, for your throttle, you're going to be using whatever that OSB or plywood is. And then you're obviously going to be using some form of bulk water management or air management at that point. That's going to have some permeable detail. It depends upon what that MDI resin would be in that panel, but it's not going to be zero. So if you did have a catastrophic amount of water in that wall, it's not only going to be able to dry to one location interior, it's now going to be able to be pulled out to the outside and dry out as well. Think about some of those hot 80-degree days that we've not had a lot of yet, but that's going to allow 2-directional drying for you, where in the past maybe that's not been the option. So we're not just talking about thermal for dealing with Mother Nature in the wintertime, but also cooling as well. The next setup, the next piece here is going to be talking about heat gain. And everything we do in the United States is always driven off an R value for thermal, right? For windows, it's U value. In this case, when you look at it in this scenario, I've teed up a couple of different things. I've got an XPS foam on the left, which is an R5. Mineral wool is an R4 per inch. And then we've got the wood fiber, which is 3.6. So from a performance standpoint, the wood fiber should not perform as well as the flanking left and right materials. But here it's a little bit different. We're talking about heat gain. And I've got a couple lights here that I'm going to flip on in a second And what you're going to see is that that R value really doesn't apply to this application. So now it's summertime. We've turned on the heat. So by all rights, that wood fiber should be a higher number, but what you'll see is quite the opposite. You'll start to see that the other materials aren't nearly as robust at holding back that heat gain. So what that's going to allow you to do in this application is now you're not going to need as much of a load on that cooling equipment that you're using in the inside. So the point of this slide is that, you know, just one R value per se isn't going to tell you the whole story as it relates to any material. And in this case, we're talking about wood fiber. Shamelessly, every month, the third Thursday of every month, we do a virtual session called Beyond R Value, where we start to nerd out and get into some of those types of details that are quite interesting. And then that vapor open piece and the fact that there's non-toxics here, you know, now maybe perhaps using this material, this system, if you will, you might not need an air exchanger. We're building so many of our buildings so tight now, we worry about, you know, the stale air, if you will, and trying to have some of that air exchanged, particularly during the heating months. You might not need to necessarily do that. And then also we're looking at the insulation as acoustics as well too. And by and large, it's 90% wood. The wood fiber is more 95% non-toxics, easy to work with. Also not going to be any chemicals into the air that are toxic to breathe in. So no concerns there whatsoever. We are going to be doing all of our ESR reports to verify fire, R value, performance, all of the above. That's quite simple to do. That takes about 2 months after we've come offline, and we're going through that process right now for the fill. Rest assured, we'll be doing declare labels, life cycle analysis. Those take a little bit longer, but we'll certainly have those available for you as well too. The product, you know, certainly from a circular economy, first off, we are using 90% certified wood, all coming from Maine. So that's a very easy layup for us. Our material in and of itself, what we need for material, we could actually take recycled material, think of end cuts from job sites. We do have that built into our long-term plans where we would be able to do that with our local retailers, providing with us with some of those post-construction waste from the job site. So circular economy here for sure, very easy for us to do. We're looking at trees. So photosynthesis, we're trapping that carbon. That carbon can either be off-gassed as that tree decays in the woods. It could be burned off for biomass, or it could be sequestered into a 2x4, in this case, a wood fiber insulation. But really, this is the game changer. Now, cellulose isn't represented here, and I want to make sure that everybody knows that that is still a very viable product with less carbon outputs because it is recycled material, but it's not represented here. But you know, the wood fiber, you know, here's a category within a category that for applications where it's wood frame construction, there's a nuance here that's not available. Most of the materials do a fabulous job in terms of reducing our operational cost. Some of them do a fabulous job with, you know, type 1, type 2 non-combustible, where they can get saturated and there's no concerns, but the embodied carbon is an area that's of suspect. So all we're really wanting to make people aware of is that there's a new alternative, a new product that's viable, that's economic, that meets the budgets, that might have a great opportunity in areas where other materials have been being used at this time. I look at it as an integrated solution. You know, if it's a house you're building, you might find now that if you have been using some of these other materials, maybe wood fiber is a good fit. But in and around that foundation insulation, maybe that you would still use perhaps a mineral wool or something like that. It helps to reduce perhaps the percentage of some of these other materials that have been used at that period of time. And this is really the big overarching goal, and I'm sure many of you are fully aware of this, and many of you I know attend different seminars, AIA, Passive House, NESE and such, but concrete is really the area of greatest opportunity to drive down carbon emissions. And believe it or not, the insulation category is right up there towards the top of the list as well. And I'm going to pause for a little any other questions, Aaron, that might have come up? And I do have a couple of little brief slides as we wind down, but I did want to allow time for any group questions that we may want to get into.
Great. Thank you, Scott. There's a couple of questions in the chat room I'll read through, and folks continue to ask others. And at this point, if you want to ask a question directly, you can just go ahead and use the raised hand feature, and I'll let you unmute and ask your question directly too. But we have one question in here concerning the sustainability of the timber industry overall. And noting that, at least for this person, they have a difficult time getting FSC certified wood for some of their projects. And is this going to present, any challenges for that? Is it going to compete with that in any way? Or, if you could just broadly comment now on sustainability of the forest industry.
That's a really great question. I think a lot of it, maybe I'll use LEED as kind of the talking point, right? So it is extremely difficult to do the, I'm trying to find out, chain of custody, if you will. So one of the biggest problems for the certified piece and making sure whatever product that you're building is compliant, if you will, is that chain of custody. Like for us, we're buying lumber from or the wood chips in this case, from a number of different suppliers. And in the individuals that are going and harvesting that have their certification, if you will, in Maine, for example, a lot of that is private woodlots. And so if I'm a manufacturer such as I am with Timber HP, and I've got loads coming in from various different locations, if I don't have a setup to make sure that, okay, I'm only going to have this collection site going to be from certified chips in this case, and if I'm integrating them, it's almost impossible for you to verify that chain of custody. It's plenty of certified wood out there. It's just that it's a laborious process, be it a 2x4 manufacturer, interior trim company, or a window and door company that's sourcing wood. I think the biggest challenge is finding a way to get that chain of custody to get the points necessary, in this case, for LEED. More often than not, what people are looking at from a manufacturer for us, like wood fiber, is the non-toxic piece. That's an easier way to do accrue LEED points, if you will, or the R value, the recycling content. So I think a lot of it is process driven in terms of the complexity of it. There's plenty of it out there. We do have longer term goals to do it, and we're picking up where the paper industry left off. So we're not going to be putting large demands onto the forest industry to take away and create any hiccups for anybody else that's out there that's procuring certified wood. I don't know if that answered the question, but we absolutely longer term want to be finding ways to label our product to get into that granular level to go after things such as LEED. But it's a tedious process to manage the raw material coming in. That's really what I'm trying to help people understand. Thanks, Aaron.
Yeah, thanks. I think that got at the question, but feel free to ask a follow-up if anyone has one. There's another question here, which is noted that you sort of addressed already, but talking a little bit about the fire, smoke, and moisture implications. You obviously talked a lot about the fire implications, a little bit of moisture. I do notice you mentioned, how this material is great for dealing with moisture as long as it's allowed to dry out. For example, the board, you wouldn't recommend putting, under or for say foundation insulation. So I mean, is there anything else you can talk a little bit about?
That's a great,
about how it deals with bulk water, for example.
Right, great question, right? Especially since it feels like we live in the Northwest nowadays. So we're gonna crawl, walk, and run. If you go to the European sites and look at some of those companies I showed you, they get a little more bullish in some of their applications. We purposely are right now going into the wood framed details, but we actually do see pathways, for example, inside a building. In fact, I've got to follow up with one of the universities in the greater Boston area where they're repurposing an old building and they want to put interior continuous insulation up against masonry. We see pathways to be able to do that. What we're trying to eliminate is standing in a puddle where it never dries out. The material is amazing. In fact, at our trade shows, we'll throw it into a bathtub, if you will, where the materials just sits and stands in waters for days at a time. We'll pull out some of that material, let it sit air dry, and the shape and form still maintains itself. I go back to that photo in the presentation at Mount Desert Island, same thing. That stuff was abused quite heavily. The bottom line is it just needs to dry out. It is no different than a piece of plywood or a piece of OSB. It's that robust in those applications. Good questions. These are a couple of other things. We can answer some more questions, Aaron, as we go along, but just to try to give those on the call here a little more vote of confidence. Josh and Matt have brought in a lot of great folks to work with us. Jason Todd, for one, he came from the cellulose industry, and we're partnering with a lot of phenomenal resources out there to make sure that our product is not only meeting code, but also is going to be a robust, long-lasting material out there. And you can see some of the different companies that we're working with. Many of these are the same folks that we'll be working with to make sure our products are code compliant for both the US and for Canada as well. So the due diligence is definitely being taken extremely serious. We could sell out the plant in 2 minutes. We don't want to do that. And what I mean by that sounds a little arrogant. Didn't mean to come off that way. Because our facility can only output so much, we want to make sure we get this out into the Northeast so that people can specify it, build with it, use it, learn from it, and get the momentum moving in the United States so that we can provide this as a very viable commercial opportunity across the United States. And so what I mean by we could sell that out, there's a lot of companies publicly traded that have their ESG reports, and they're very, very large. They literally could say, okay, I want to buy that volume and that volume and that volume for fill, bat, and board, and I want to use it exclusively so that I can put that into my shareholders note. And we've had a few folks that have knocked on our door wanting to do that. Now that's great if you want a quick return on your dollar for those investors. Our investors are not venture capitalists. They're investors for the technology and for the long run. So all of this is being done to be able to make Madison an extremely successful plant and get the product out into all of those categories that I had mentioned. That's another reason that we're not in the big box as well. We want to go through independent retailers that know the products that they're working with and know how to sell it. Here again, product certifications. These take a little bit longer to get. When you look at the Declare label, for example, when you look at the LCA and EPD, those take about 12 months. We have put aside the monies available to make sure that we go after those certifications. So we're going to absolutely do those due diligence to make sure that we're able to do it. We're also going to do a lot internally on the marketing side, on the education for consumers. Most of you on this phone call, there was really nothing really new related to sustainability or carbon, but I'm sure your clients, sometimes when you speak with them, are scratching their head. We'll have a 90-second video we're going to put out at the US Green Build show down in September down in Washington. That's really creative, that discusses carbon as it relates to the building environment. So there'll be a lot of support material available for you to use when you're working with folks. And we certainly have the marketing team background, and we're building the sales team. I'm the young lad down there at the bottom. So I'll be your source right now for the interim, and I'll be sending my contact information through with Aaron. And Addie Atkins may be joining us. She's starting July 10th. She'll be the local resource for you in the Massachusetts and Vermont markets. But in addition to our dealers and our distributors, we'll have folks that are available to be out working with you in your offices and also on the job sites as well too. So we'll also have what we call the field education specialists, building envelope experts. So for some of those commercial jobs you might be involved with, or a large weatherization program, if it's the first time you've used the material, we're going to make sure that we're available to hop out on that job site so that you're not going it alone. And that's the level of resource that we want to put in, not just for the technical support, but also for boots on the street as well too. Aaron, any other questions? Because I think I've got up against that 1 o'clock time frame.
That's all the questions that have come in. If folks have any last ones, definitely get them in right now. But Scott, I want to thank you for this great presentation. I'm excited to see this product coming on along here close by. Just as a note, we had for Pascal's Mass, and we did a workshop here with the Studio for High Performance Design and Construction, a pod construction workshop last fall, and used one of the wood fiber boards from one of the European companies, and found it really easy to work with. It was a great product to both cut on site and install as exterior installation. And I'm really looking forward to an opportunity to use a local product here later this year.
Well, that's great, Aaron. And I want to thank everybody that joined us, and you'll get my contact information. Please use it. We do have an AIA presentation that's worth one health, safety, welfare credit. It's Wood Fiber 101. If you're interested in having me come into your firm, we'd be glad to do that. And again, thank you for your interest and thank you for your time today.
All right. Thank you, everyone. Have a good day.
Thanks, Aaron.